Hello, everyone. My name is Joris Peels, and this is another episode of the 3D Printing News Unpeeled. Today, we've got a couple of news items for you in the top additive manufacturing 3D printing news of the day. The first one is Voxeldance Additive 4.0. This is the new version of the all-in-one AM build prep software from Chinese startup Voxeldance. So Voxeldance has build prep software for SLM, or powder bed fusion for metals, SLA, or vat polymerization, just regular sintering and polymers, and DLP as well. It's an alternative to Magix, which is, of course, the gold standard in 3D printing. And it's nice, I think, that we have competition, to be honest. It's nice that we have for build preps of their other options, of people competing with them. Currently we've got Autodesk, Magix, or Materialized Magix, and pretty much only Voxeldance really is competing in this space directly. There's other companies like Octom, which are part of 3D Systems, that are offering comparable software to some of the features. But no one's really, head-on taking on Magix. What I like about Voxeldance is that it's really looking at kind of things like shoe molds, jewels, industrial molding applications, trying to come up with workflows. And kind of similar to what Octon has for, but then in a kind of more accessible way to people on the desktop, if you will, or working from their offices. They claim also they've got better improvements in efficiency, print success rate coming up in the new version. And there's some new versions, or some new features, which you can see in front of you. And they include like the ability to shrink wrap parts and smooth meshes. And these kind of automated features are things that I always really love about Magix, where you kind of just don't want to flip all the triangles, let's say. You just want to have an automatic mode that does not distort your model that much, but does actually solve all the problems in one kind of magical, quick button press. So that's good for me. I think, it's good for the industry to have competition in these kind of markets. So good for Voxeldance and pushing this product forward. The next bit of research is a bio-based formulation of electric conductive ink with high potential additive manufacturing by direct ink writing. This is a paper that is actually really quite exciting, because what they do is they use a bio-based thermosetting resin, which is already quite an exotic material. That's a binding material. Then they have additives, essentially cellulose powders, to get the correct rheology to let the direct ink write process work. And then they add in carbon nanotubes as conductive fillers. This then goes into a direct write process. The schematic is just a generic schematic of direct write, which essentially, as you can see, is a gantry type system with a compressed air pressing on an ink that is then extruded through a nozzle. That's a direct ink write. Now, that resulting nanocomposite material is then carbonized. We're seeing a lot of work here with people carbonizing prints after they're made to get a higher conductivity from them. And this is also the case in this paper. What the team even claims is they hope to get tunable electrical conductivity, so we can change the number of conductivity through carbonization or constituent materials. The team sees their invention as going towards making integrating conductive circuits and into 3D construction of parts, right? To have integrated complex circuits, making semiconductor materials and complex constructs, and making, using this low-cost direct ink write, or comparatively low-cost direct ink write technology, and these low-cost materials to make kind of really complex, high-order devices. So I think that's, to me, that was a very, very exciting piece of research today. Another piece of research, this is actually from that piece of research as well. You can see some of the pieces they made. And another piece of research, and what this is from, comes to us from Tsinghua University. And that is this is even more sci-fi than the last one, I think. This is the 3D printing of semiconductor quantum dots. So what they've done is they've created a laser direct writing technique. And that technique is called photoexcitation-induced chemical bonding, where they're essentially trying to get the chemical dots themselves to bond chemically using the 3D printing laser. And then they're making out of that structures, as you can see in front of you in the graphic. This structure could mean that we can create sensors in this way. We can create light-emitting devices in this way. We could do shaped LEDs. We do LEDs that function kind of as a lens or project things in a certain way. You could even think of maybe people making display technologies and things in this way. To me, this is also very exciting that both these research items with the bio-based inks And this is very, ahead of its time. Let's say this. I don't. It'd be difficult for them to find applications for this technology now. But if both of them as a way to explore future integrated 3D printed items is very, very exciting, I think. The next thing is Boeing giving a contract to Symbrix. So Symbrix is an Israeli firm that does virtual machining, virtual manufacturing, and digital thread remotely as like a kind of a software package. And the digital twin and the digital thread are things that really routinely fill conferences, but they're not really that well known or that well actually used on the shop floor. The idea is to make a digital copy of your entire product, let's say your tank or whatever, and then to also make a copy of the constituent parts and to track all these parts in digitally, let's say. So you can, from the initiation, from the moment you sketch something and design something, to the moment you ship it to your customer, or maybe even beyond that moment, where to track maintenance intervals and how the real world affects it, you can track that thing. So a kind of a virtual copy of your real thing, if you will. Um, Part of this is kind of like stuff that your PLM and ERP and all this other software you have is supposed to do already. So I'm really curious, when this kind of stuff keeps getting promoted, where does it actually going to live in the enterprise? Right? Is it the solution? Is it going to be the main interface layer for your company? Is it going to be the main layer through which you share and make accessible actually build files, right? Or is it going to be the main way you organize all of your files and your data and your design process in your company? So there's a lot of people talking about this vision element, but I see very little going on. So I'm always curious about this, and this is a kind of a sign that stuff is actually going on beyond people making speeches about it. So Symbrix is getting in contact with Boeing Missile Defense. It disclosed in this announcement, by the way, that Boeing as a whole has printed over 70,000 parts, which I think is higher than the previous announcements that they disclosed. This is also including military aircraft and civilian aircraft and things like missiles. Missiles in and of itself is not really, it's not really widely talked about because at the moment, but we know that there's extensive patents going on in missile defense, where we know that there are 3D printing warheads, they're 3D printing several stages of this, engines, combustion chambers, lots of different components are being 3D printed on these things. And all we know that all the commercial space companies are using 3D printing to make their rockets, and the same logic for a rocket and a missile applies. It's essentially very much the same thing. So if we can make a better rocket, we can also make a better missile. So it's just one of the cases of like this whole missile defense business, which is using 3D printing extensively, not only for the rockets themselves and the warheads and the engines, but also in some cases the fuel grains, and also in some cases some other components, such as, for example, radio frequency components and radar kind of components as well. It's just a really small sign of this industry coming, saying something, if anything, publicly about what they're doing. So the exciting thing I think about this is that what Boeing wants to do is to manage IP across vendors. So it's going to outsource the production of parts extensively, probably towards local Israeli vendors in this case. And it may have outsourced other parts as well to US vendors. There's going to be a lot of legal stuff. There's going to be some IP considerations. There's going to be some kind of considerations that Boeing wants to print exactly the same part in the way that it wants it printed, with the right settings and everything. So if it uses this digital thread software by Symbrix to correctly manage this entire process, then I think this could be very valuable software to them. But where is this going to live in relation to everybody's CAD package? Is this kind of digital thread software going to be the de facto way that people work with contractors and subcontractors and services? Because that in and of itself could be a very exciting way for the software to function, right? Or is it going to supplant existing ERP, PLM type of packages and bring to the table the kind of collaborative experience that PLM was supposed to give us years and millions of dollars ago? I don't know. So that's why I'm interested in this kind of thing. And I think a lot of people, are talking about the peaceful applications of 3D printing, which have to be celebrated. But we have to understand that the military kind of applications are considerable, and there's a lot of people working behind the scenes on that as well. We should, as an industry, take responsibility for that and not ignore that. Anyway, thank you very much. My name is Joris Peels, and this is another version of 3D printing news Unpeeled.